All right, so let's get started. My name is Michael. I'm the Senior Director of Products at Apprenda. A lot of my role at Apprenda includes the product direction, a lot of the investments we're making in our platform as a service, as well as working with customers and partners. At the same time, I'm also the SIG Windows lead. So I work with a team of folks. A lot of them are here today. So we have G2, Alex, and a couple of others that are heavily involved in the process of bringing Windows Server containers and Windows Server support into Kubernetes. So our goal from the beginning was there's an ecosystem of applications and servers out there that, as well as companies that have made investments into Windows, and they want to see those investments into Kubernetes and be able to take advantage of the larger ecosystem and all the efforts that are going around in Kubernetes. So who are we? So most of the team in SIG Windows, at least the active team, is comprised out of Apprenda members. We are a company that created a platform as a service solution that makes it very easy for developers and IT operators to create a self-service platform as a service solution within their enterprise. So you have your own hardware, you install our software there, and you get an ecosystem of apps and services that allow you to power line of business applications. We kind of bring that many years of experience in containers, Windows Server, and our DNA in that ecosystem into Kubernetes, and that's why we're heavily involved into the SIG Windows team and try to take those lessons learned, allow Windows Server containers to be onboarded into Kubernetes, and then be able to host applications like IIS, ASP.NET, and any other .NET application into Kubernetes. As a company, Apprenda, we've been part of the Kubernetes community through an acquisition we made of a company called Kismatic, and we've been heavily involved into software and solutions into the community since early March of this year. So what are some of our goals as a SIG Windows team? Like I mentioned earlier, our goal is to bring Windows Server and Windows Server containers or HyperV containers into the ecosystem of Kubernetes. That will allow Kubernetes to be able to expand the types of applications that are supported. So that gives you a true heterogeneous hybrid environment between Windows and Linux, Java, .NET, and so on and so forth. That allows us to kind of leverage the investments that Microsoft as well as Docker are making into this ecosystem. And as a byproduct of that, we're able to loop back to them and drive enhancements into Windows networking. And we're going to deep dive into that later on. If we look at Windows Server as an operating system, there's a ton of Windows Server out there in the enterprise. There's 37% Windows Server operating systems in traditional enterprises today. If you look at Azure, and this is a little bit, it's not the representative of true enterprises, but in Windows Azure, 80% of the workloads are on Windows Server. And there's almost 12% of all the web servers out there that are running IIS. So there's tremendous need for supporting workloads running on Windows and .NET in general. In a survey by Gartner, they say that 85% of the enterprise software in the global 2,000 IT organizations will still run Microsoft and Java software through 2017. So .NET is not going away anytime soon. So I kind of gave you guys a little bit of background why we're doing this, and there's a true need here for Windows. I'm assuming that a lot of you guys are here because you care about Windows. So let me get started. How many of you guys have tried Windows Server containers or HyperV containers so far? So a few of you? Very cool. So looking at the Docker architecture here, a couple of pieces that we had to modify to make it work for Kubernetes were mostly centered on networking as well as compute. But the one thing that made things simpler for us as a SIG Windows team was the fact that Microsoft made Docker its de facto standard and API for utilizing Windows Server containers. So what that made possible is to have an infrastructure on the left side that has your Docker engine, daemon, the images, as well as the containers running on the Linux host, and be able to talk to the Docker API and the Docker client and have a very equivalent API set on the Windows side with a very similar architecture. So you have your Docker images that are coming from the Docker Hub. You have your engine that's been able to, that the API can talk to, and you have one by one all the different containers that you can run on top of the Windows server. Now, there's two types of containers in Windows Server today. One of it is Windows Server Containers, which is a shared kernel mode where all the containers share the kernel. And there's a little bit more secure solution that gives you better isolation, but at a reduced latency of starting up your containers and basically also more resource utilization, and that's called the HyperV Containers. The API set is the same. It's just a simple flag that you change when you're starting up your container. For most of the work that we're doing today and the demo we'll be showing you is all about Windows Server Containers, but the same lessons can be applied to the more isolated multi-tenant solution of HyperV Containers. Taking a brief look at the production cluster example of Kubernetes, you have your master components like your API server, your scheduler, the controller manager, load balancer at the left. You have the kubectl. You have your etcd cluster up on the top. And then you have your worker nodes, which are the different nodes that you brought into Kubernetes. So you have your kubelet, the kubeproxy, and one by one the different pods with the containers running into them. So when we started architecting our solution, one of our main goals was we didn't want to modify anything on the etcd or the master components. We wanted to concentrate all our work into an abstraction layer into the kubelet and the kubeproxy so that it makes it easier for us to kind of advance our strategy independently of the master components. That was similar to what Rocket did to introduce support for Rocket into Kubernetes as well. So looking at what we did here, you have the kubectl that's unchanged. You have your master components that are unchanged. And then on the Windows Server 2016 node, you have modified the kubelet, the kubeproxy. We still run Docker because that's the API layer for Windows Server Containers. And then you run one or more containers in the pod along with the infrastructure container. On the front end, the kubeproxy talks to the external networking interfaces. In order for us to add the Windows Server node to Kubernetes, we had to make a few changes to support the Windows Server OS. This was the first time that a new type of operating system was added in Kubernetes. So there were a lot of assumptions in the code that assumed you're running on a Linux OS. It used Linux primitives and other things that we had to go in and find them one by one. It was more of a trial and error process until the point that we changed all of them. But the bulk of our changes and most of the complexity was around networking. And we're going to touch those points in a second. However, at the end, when we're able to finish this, we're able to schedule Windows Server Containers. You can run IIS workloads in Kubernetes today. You can run ASP.NET. You can run .NET Core components. Actually, .NET Core allows you to develop an application running on .NET Core and run it either on Linux or Windows. So you can essentially create a container and create a hybrid installation where the same container with that workload of ASP.NET Core or .NET Core can run on any of the two types of containers that can run in Kubernetes, either Windows or Docker on Linux. When you think about networking, there's kind of two main pieces of networking that I want to discuss today, and I'll discuss the intrapod and the interpod networking. On the intrapod networking, that's the communication that containers within a pod get to talk to each other. In Linux, they kind of share the same networking namespace. So that means that the entire pod has a single IP address, and all the containers within that pod can communicate over localhost. In Windows, the same abstraction did not exist. So it's not possible for you to use container mode networking. In Windows, each container will have its own IP address. And there's different networking modes that they allow you. So they have a NAT mode, where you have a NAT on the container host, and then all the containers can pick up an IP address from the NAT range. You can have a transparent network, in which point every container in the host gets its own IP address, and it's directly attached to the physical interface, the physical virtual switch. They have also L2 tunnel and L2 bridge and a few other technologies. We've concentrated on transparent mode, where every container has its own IP address, and that's what we built our solution on. But that means that every container gets its own networking stack. So you no longer have the ability to put many containers in a pod and all of them to share the networking stack. Every one of them has an individual thing. So that does not allow us to achieve parity with the Linux pod abstraction. And we're working on how to rectify that in a future release. On the interpod networking, that's the ability of containers and pods to be able to communicate with other containers and pods on either the same host or other host. There's no SDN plugins in Windows, so you can't do things like what Calico does today. So there's no overlay networks, at least not natively in Windows Server today. So in our case, what you couldn't do is you couldn't get given a single IP address to a pod that's routable across the entire cluster. That doesn't exist. Each container has its IP address that's routable across the cluster. In order for us to actually implement a lot of the routing, we had to use RRAS, which is a feature of Windows Server, as well as routing table manipulation and port forwarding and packet forwarding in order to make all of that magic work under the covers. So when we're continuing down the networking path, kubeproxy had a lot of networking challenges for us as well. So there's no IP tables on Windows Server. So the same functionality that you get on Linux from a single solution, IP tables, is scattered through many different variants on Windows Server, and some of them is not even existent. So what we've done is we've used NetSH port proxy to do a lot of the work around redirecting and DNADing the network packets, but that doesn't support UDP. So that means that DNS, if you're trying to do a DNS query from within a container, won't be able to forward your packets. So then it relies on the DNS client to be able to re-query over TCP a second time in order to make all of that work. So we're working with Microsoft to kind of rectify this as well and make sure that UDP is supported on port proxy. Then another thing that came out was that we had to implement the proxy in user space. So that made it a little bit simpler for us, but it was more intensive from a CPU perspective. In all our tests, we didn't find that to be prohibitive from a resource consumption, but that's just something that we have to worry about and keep an eye on in the future. And obviously, the Windows firewall in Windows behaves a lot different than how IP tables behave in Linux. Kind of mentioned this earlier, so let's dive into a demo here. So I'm going to show you guys an environment that has 2 Windows Server nodes. They're running Windows Server 2016 RTM, and 1 Linux node that will contain all of the Kubernetes core components. That's the master components, the DNS, IP, server, and all these things. For the application that we're going to use the Guestbook Go application. That's an app that ships you the distribution of Kubernetes. So you can run this app on Linux or on Windows. For the purposes of this demo, I'm not going to show you a hybrid installation, but I'm going to run all the components on Windows. And the app has a Redis backend that's been remodified to run on Windows. So let's switch here. The first thing I want to show you guys is what my environment looks like on Azure. So I'm doing this demo entirely on Azure components. So we have a cluster of 5 nodes. We'll use 3 of them today for the demo. One of them is the kubelin 01. That's my Linux machine, and I have my 4 Windows machines here running different versions of Windows Server 2016, some pre-RTM and some RTM. And I have 5 Ethernet adapters. Well, more than 5 here, but 5 of them that are in use. So for each Windows node, you have 1 for bridge and 1 for the regular network traffic. And in Windows Azure, the way that we've kind of deployed this entire environment using the Azure Resource Manager that allows you to templatize an environment. So we took that template, created it, and were able to re-replicate this entire installation. And one of the things I want to mention here is that the Azure KubeNet is the virtual network that kind of connects all these devices together in terms of the network interfaces across the different nodes in my environment. And the last thing is, in Windows Azure, a lot of the routing table that you need to make all that magic happen and have routable requests from a networking perspective across the different nodes, you have to define that manually within your environment. So we have our routes explicitly defined here in Azure. So let's switch here to it will probably be easier for me to duplicate my environment, so I'm going to do that here in a second. Is the quality okay that you guys can see it in the back, or everything's good? All right. So I've connected using PuTTY to my Kubernetes master components on my server. So let's go ahead here and show you all the different nodes that I have running here. So I have two nodes, the 127.0.0.1, that's my Linux node running all the Kubernetes master components, and the 10.0.1.15 is one of my Windows nodes. So I went ahead and added one of my Windows nodes ahead of time, just so I can have that up and running, and then we'll go ahead and add another node right now. So both of them have been running for about 5 hours or so. So let's go ahead and show you how easy it is now to add one more Windows node into my environment. I'm going to use my scripts here to copy a couple of things. And this is my Windows Server 2016 node. So the command that I just copied right now is basically using an environment variable to indicate what the container network will be, and it's called MyNet. And then it's basically calling the kubelet.exe with the hostname override, as well as a pointer to an infrastructure container that you get to use, and a pointer to the API server in Kubernetes. I actually copied the wrong thing, so I'm going to copy the right thing here. And this right now started the kubelet. Right now, a lot of the steps of initiating both the kubelet and the proxy are a little bit manual, but we're working on making all of these things Windows services with an installation package. So you can say, I want to add a new node into my environment. You run the installation package. It will deploy the kubelet, the proxy, set up your network, and get it all started. So now my kubelet already went ahead and started. But I want to show you guys here. If I did Docker network ls here, I get to see that the MyNet network that I just indicated earlier, it's a transparent network. So like I mentioned, Docker on Windows has many networking modes. We've chose transparent that allows us to have one network interface binded to the physical network interface per container. Now it's time to start the proxy as well. Very similar to what I did for the kubelet, I need to set up an environment variable indicating which is the network interface I want to use. And then I start the proxy pointing to the IP server, to the API server, as well as to the indicating what's this machine, what's its name, the IP address, and all these other details. All right, so our proxy now is up and running. So if I go back to my Kubernetes command and around the kubectl and I get the nodes, I see another node here, the .17 node, also up and running. So I have a secondary Windows Server node in my environment. So if I were to describe one of these nodes, you notice that a lot of the details here are very similar to what you get if you had a Linux node on Kubernetes. So there's not any differences functionally or operating these nodes between Windows and Linux. You get a very familiar experience across the board. So more importantly now, if I run a query here to see, to get all my nodes and output the data in JSON, one of the most important things that I want to show you guys here is that you get your node name, and you can see your architecture, AMD64, and it's running Windows for two of the nodes, and then you have an AMD64 and Linux for the other one. So other than that, every other aspect of the labels, the config of the nodes is the same, except the fact that two of them are Windows and one of them is Linux. one experience across both ecosystems of Windows and Linux in Kubernetes. Our goal was not to differentiate here the experience. We wanted all of it to seem seamless, well integrated across the board. So let's go ahead and create some apps and see how easy it is to both create them as well as scale them in this environment. So like I mentioned earlier, I'm going to go ahead and create a Redis application. So what I did here is I pasted 4 commands that will create the master controller and the service for Redis and the slave controller and the slave service for Redis. So what does that look like? So let's cut this command. Over here, you're seeing a very standard interface or a JSON command here that you're familiar with in Kubernetes. You have your replication controller. It's a Redis slave. In this case, I'm asking for 2 replicas. And one of the most important things here is the image here is going to come out of Windows Server Core. So that's the image that we're using here for our installation. And how do you tell it to use Windows as a target operating system versus Linux? Use the node selector and the Windows tag. So just as I showed you guys earlier in the nodes, Windows and Linux is differentiated by the labels. I can use those labels to define where each one of my workloads needs to land. In this case, I want them to land on Windows. So now I can actually call Kubernetes again and ask it to show me all the different pods that I have on my nodes. And we see here that we have 2 Redis slaves, 1 Redis master, as well as a blog engine pod. I actually went ahead and deployed blog engine ahead of this presentation just to have that up and running and have that ready. So now all my pods are running. Notice here the node which they're running. They're all running the .15 or the .17. So all my containers are running, all my containers and all my pods are running on Windows Server right now. And each of them has a unique IP address across a cluster. So if I want to check, has my Redis master and the slave synchronized, I can use standard Kubernetes commands to check that. And it looks like the synchronization with the slave has succeeded. So now both my Redis master and my Redis slave were able to find each other. More importantly, when I'm going to show you guys the application in a little bit, guestbook go writes to master and reads from slave. And all of the different components of my app, the different pods, the slave, the master, as well as the guestbook go application are able to find each other through a very primitive service discovery using labels. So using labels to be able to find where each one of these components are deployed. So now it's time to actually deploy our Go application as well. Again, very similar to what I did earlier, I have my JSON files describing my controller and my service. I'm able to call those out. And if I did a cut on one of these, you notice that, again, the targeting is on Windows. So this application will also run on my Windows server. So let's see if all our pods are up and running now. And we have the Ghost application, the guestbook application also up and running. So let's go ahead and describe our service. And so we can get the service IP address and be able to call it and see that work. Now this is telling me that my guestbook application is running on 10.0.92 IP address, and it's on port 3000. So let's copy that here really quickly. Go back to our Windows node. Have a browser here up and running, and I'm going to visit that I'm going to visit that IP address, and there you go. I have a guestbook application running on Windows. I can go ahead and enter data here. So I'm going to call it demo KubeCon 1 and 2. So we have some data that went back into the Redis backend. If I were to click on the environment variables, you notice that most of these are very specific to my guestbook application, but they are based on an OS of Windows NT. So this is running truly on Windows. And I can even click into the info here and look at some of the Redis-specific data. So we have Redis, we have the guestbook Go application, all of it running on Windows Server containers, on top of Windows Server, with the Docker API, all of that called from the kubeproxy and the kubelet, and giving you a very similar experience, a very familiar experience to what you get in Linux. You also can take advantage of all the features that Kubernetes provides. So we didn't have to do anything special to be able to use the replication controller, be able to scale, do high availability on our containers. So let's go ahead and try that out right now. So I can come here and issue a command to the cluster to increase the replica count for my guestbook to 3. So if I were to call the pods again, you'll notice now that we have 2 containers that are creating for guestbook. And with just a click of a button, I was able to increase the replica set for a Windows Server application. I want to demonstrate to you guys now that the routing actually does work on Windows. So I'm going to go ahead and grab, I'm going to describe my service one more time so I can get this IP address. And it's .92. And I'm going to call an API about 20 times from one of my Windows Server nodes that essentially what this API will do is it will make persistent IP address calls into the guestbook application, retrieving the data that we have on Redis, and at the same time also telling you the IP address that I was able to hit. So it will show the node port load balancing that the Kubernetes offers for me. So we're going to call our API call here. I'm going to click enter. And notice here that we're getting back the data, demo 1, 2, 3, from each one of the nodes. But notice how the IP address has changed to 165, 174, 201, and so on and so forth. So it's looping through all the different IP addresses, doing the load balancing. And if I want to go ahead and unplug one of my nodes or delete a pod, I'll be able to, Kubernetes will detect that and be able to stand up a new one and redirect my pods, keeping my replica count to what I had defined. So coming back here, if I were to call the pods again, the IP addresses for guestbook are the same ones as the ones I showed you earlier. Now, guestbook is a cool application. It's a multi-tier. It has the Redis backend. It has the Go front end. We also wanted to show you guys what would it take to take a traditional .NET application, run it inside a Windows Server container, and bring that into Kubernetes. So what we did is we went to the GitHub page for Blog Engine, we downloaded the binaries, and we built a container out of it, all a single enclosed container of the Blog Engine application, and published it. So I went ahead and created a pod for it. So let's go ahead and describe that service, and we're going to go look at that. So now our Blog Engine is deployed to IP 120 and port 8000. So if I go back to my user interface here, and visit this, I get to see a traditional .NET application running on Kubernetes. We didn't have to do anything extra. We took a vanilla .NET application, we put it inside a container, and we were able to run this. Now, not all applications can run in a container. Containers on Windows support only Nano Server and Windows Server Core. So if your application can run on either of those 2 OSs, and one of them has a limitation on what .NET you can use, so Nano Server can only run .NET Core. But as long as you can live with those limitations and you can put your application on any of those 2 OSs, you can package it in a container, you can run it in Kubernetes using Windows Server containers. So this is a fully functional app. I can go ahead and log in here. I can see the admin interface. I can do search. It has all the data that Blog Engine needs to be able to function as a valid multi-tier application on Windows. All right. Any questions so far on the demo before we switch to the rest of the slides? Go ahead. So the question was, how about persistent storage? The volumes and storage on Kubernetes, we're actually working on that. Some of that functionality is going to be available for you when we go to alpha with version 1.5. But secrets as well will be available. And we're also going to work on getting config maps up and running for Windows Server containers. So the question was, if you run HyperV containers, can you run Linux on them? HyperV containers still have the same limitation in the OS that it has to be the Nano server or Windows Server Core. So you cannot run Linux containers in that. You can use a HyperV virtual machine if you want to run a Linux OS, but then it would be a virtual machine. It would not be a container. Yes?
For the Kubernetes services, you get assigned a cluster IP or a virtual IP. You can also use DNS. Does DNS work in this deployment?
So I'll touch on that in a little bit. The question was if DNS will work in this deployment. So DNS from inside the container will work if your DNS client is a little bit resilient and be able to fail. The fails request will come over UDP and that will fail. If you reissue the request, it will go over TCP and that will succeed. However, DNS search does not work. So when you're making DNS queries, you have to use the full FQDN of the resource that you're trying to discover.
Is that something that is actively, is that something you're
Yeah, that's something that we're actively trying to solve. Let me go back to my presentation here. So today we run a couple of containers. We run the infra container as well as the container of your choice in the pod. It's not advised to do that today just because a lot of the same functionality that exists in Linux does not exist in Windows, so we can't share the storage, we can't share the network namespace. Our goal is to get to the point that we can give you a full solution that allows you to run multiple containers in a pod. You can use sidecars, you can use init containers, and have that similar functionality to Linux. We'll get there fairly soon. We're confident of that. Just today is not there. Yes?
One more, sorry.
Yeah, that's okay.
You said alpha by 1.5, and then from there, what do you think for hardening and supporting a release?
So today, all of the things that we showed you guys are available with 1.5. You'll be able to download the code, try things out, and deploy your containers and provide us feedback. Like I mentioned, it will be alpha in 1.5. 1.6 will probably come sometime in first quarter of 2017. We can't promise that it will be better then because a lot of these things are requiring changes into Windows from a networking side, as well as certain kind of pilot projects that we're working on to try some alternatives to supporting that. If everything goes well, we'll definitely be in beta with 1.6. But we can't promise that. We'll probably have more clarity within the next month or so. So our goal is releasing this with 1.5. The beta release will include a lot of the networking enhancements that we're working on, as well as monitoring, setup, and configuration. So make it easy for you guys to deploy that, get a brand new node, running Windows Server, get Docker up and running, install the kubelet, as well as a kubeproxy, and be able to register it back to point to the Kubernetes cluster. At the same time, we're heavily working with the Windows networking team to add support for native overlays, so we can do SDN type solutions. We're wanting for them to implement container mode networking, so we can have the pod abstraction to be equivalent on Linux and Windows, as well as some of the DNS server enhancements that we talked about so far. If you guys are really interested about this, call to action, come and get involved. We have a Slack channel that's fairly active, mostly by Apprenda folks right now, but we are welcoming anybody else to come and join us. And below that's our GitHub page that includes a lot of the code that we're working on. And actually, both of our PRs got merged into 1.5 late yesterday. Go ahead.
One question about, is MyNet
So I've actually been asked that question a few times so far. The question is the Kubernetes master running on Windows in the roadmap? There's a couple of pluses and minuses into that. The positive is that most of the master components are written in Go, so ideally they could be portable into Windows. However, we are not, as a SIG, investing in that effort for a couple of reasons. The first one is it will require massive undertaking to port some of the assumptions that the code is making that is running on a Linux operating system. So kind of changing all those assumptions like we had to do it for the kubelet, it will be a massive effort. And the second thing is we have to test all of that. So right now it's working very well on Linux. I think that keeping the hybrid solution where you have Linux and Windows up and running is a good bet for us. And then we can concentrate on giving you the best experience for running your containers on Windows without kind of messing around with the core components. Yes?
How much support this is getting from Microsoft?
So we are involved in terms of working with them on a week-by-week basis. We have a lot of conference calls with them. We're brainstorming around solutions, specifically around networking. So we are getting support from Microsoft. We do want more Microsoft folks to come and join the SIG, so they're actively involved in the day-to-day operations. I'm hoping we'll get there. Maybe this one releasing in alpha with 1.5 is exactly what Microsoft needs to jump on the ship and be more active in the SIG. All right, any other questions? I think our time is pretty much over as well. Take one last question if anybody has one. Oh, all right, well, thank you guys, appreciate it.